All right, and in this final lesson, we're going to learn how to use two various formulas that relate to graphing. We're going to learn how to use the midpoint formula in order to find the midpoint between 2 points on a graph, and we are also going to use the distance formula to find the exact distance between 2 points. Okay, so we're going to start off with the distance formula, and the distance formula uses 2 points and is as follows. So the distance between 2 points is equal to the square root of the difference between the two x-coordinates squared plus the distance between the two y-coordinates squared. So if I label my points as x1, y1, and it doesn't matter which I pick as long as I'm consistent, and x2, y2, you can see there that I would essentially take these points and substitute them into the problem above. So again, it doesn't matter which point is point 1 and which point is point 2. It just matters that you're consistent in your labeling, and then you use that as you go through. So if we substitute in these points, we're going to find x2 is 6 minus x1, which I can see is 0, squared, plus y2, I can see down here, is negative 2, minus y1, which is 4, squared. So I've taken x1 and y1, x2 and y2, and substituted them in. Now if I continue showing my work here, 6 minus 0 is 6, so I have 6 squared, plus negative 2 minus 4 more is a negative 6 squared. And then if I keep continuing, 6 squared I know is 36, plus negative 6 squared is also 36, so it's the square root of 72. I know that if I were to simplify the square root out from earlier this chapter, it would be the square root of 36 and the square root of 2. So I know that in simplified square root form that the distance between my 2 points is square root of 36 is 6 times the square root of 2, which is approximately 8.49 units, which makes sense. That looks like it's about 8 units. So note that I will expect you to be able to use the distance formula to simplify your answer to simplified square roots, as well as to get me a decimal approximation. Now, before I move on to the next slide, I want to actually talk about where this distance formula comes from, because really it stems from the Pythagorean theorem. And what you'll notice is that if I kind of connect and say, okay, I'm going to draw a vertical line and then draw a horizontal line, you can see here that if I connect points A and B by just moving vertical and horizontal, that I essentially form a right triangle here. So you can see that I have a right angle and I form a right triangle. Now we know because of the Pythagorean theorem that a squared plus b squared is equal to c squared. Now if I look really carefully at this, I know that my change in x values here, so right here, to move from 0 to positive 6, b is equal to 6. And if I look right into my distance formula, that is there. I have the 6 squared. Then if I look at a, I also see, well, to move from 4 down to negative 2, well, I moved down 6 units to get to that point, which, if I look right into my distance formula, again, negative 6 squared is in there. So really what's happening is I'm taking the Pythagorean theorem and I'm saying, okay, negative 6 squared plus 6 squared for b is equal to c squared, or my distance, squared. And from here to get c alone, what I did was I essentially square rooted both sides. So I ended up with c, or my distance, is equal to a negative 6 squared plus a positive 6 squared. And you can see how the distance formula is really just an application of the Pythagorean theorem that we learned yesterday. Kind of a cool application. So if you ever forget the distance formula, what you can do is you can create a right triangle out of your picture, like we did here, and you can use the Pythagorean theorem to help you instead. So now I'd like you to use your knowledge of the distance formula to actually apply it here to find the distance between 2 points. And we're trying to find the distance between the point 2, 3, which is approximately right here, and 4, -1, which is approximately right here. So if I use my distance formula and I label these to be points x1, y1, x2, y2, I know that my distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And so now if I substitute in my values, x2 is 4, x1 is 2, y2 is -1, y1 is 3. So I've subtracted the x values, subtracted the y values. I know that 4 minus 2 is 2 squared. I also know that -1 minus 3 more is a -4. 2 squared I know is 4. -4 squared I know is 16. So I have the square root of 20, which I know I can rewrite using my knowledge of simplifying square roots to be the square root of 4 times the square root of 5. So this, at the end of the day, the square root simplifies to be 2 times the square root of 5. So there's the simplified square root answer. And then if I plug that into my calculator, I find that this is approximately 4.47 units. So I would expect to see both of these on your paper, the simplified square root as well as the decimal approximation. And again, remember, if you forget how this works, if you forget that how to find that distance between the 2 points, so that pink line there, you can always draw in a right triangle. And here we'd find a side length of 2, a side length of 1, 2, 3, 4, and then you could apply the Pythagorean theorem instead to find that distance there at C. Now, something to note about the distance formula and its tie to the Pythagorean theorem is there are times that we're trying to find the distance between 2 points where it's actually pretty challenging to draw the picture. So here's an example. We have points that are very, very far apart, and actually drawing out the triangle is fairly challenging. And if I were to label these as x1, y1, x2, and y2, while I could draw a picture, the best option here is for me to actually use this distance formula. So if you like using the Pythagorean theorem to help you, that is 100% okay. But something to keep in mind is there are times where the distance formula is helpful just because those numbers are so large. So to kind of give you an example here, if we plug in those values, we have 21 minus a -17. And then I have -6 minus 9 more. So here I can already see I have some fairly large numbers. Then 21 minus a -17 turns into 21 plus 17, which turns into 38 squared, plus -6 minus 9 turns into a -15 squared. So again, really large numbers. 38 squared is 1,444. And -15 squared, is 225. So these numbers are pretty intense and pretty large. Now if I add those two together, 1,444 plus 225 leaves me with the square root of 1669. And if you have something this incredibly large, odds are I will just ask you for the decimal representation. So I won't actually ask you to simplify a square root that large, which in this case, the distance between these 2 points is 40.85 units. So kind of keep in mind that there are times where the distance formula is extremely helpful and drawing a picture and using the Pythagorean theorem is not. So in addition to using this distance formula to help you find the distance between 2 points, I will also be asking you to use it to help me find basically what value in the coordinate will provide me with a distance of 5 units or something like that. I'll give you a distance and you will actually have to find the coordinate or coordinates that will make that true. So here I give you the majority of the coordinates, but I don't give you y2. So if I start off using my distance formula, you'll see here that I gave you the distance. The distance actually is 5. So here I can substitute in the distance. I know the distance is 5, and then I can plug in the rest of these. I have 7 minus 3 squared plus y2 is b minus a negative 5 squared. And now if I start to simplify this out one more step, I get 7 minus 3 is 4 squared. I can't really do much with this right here. I have b plus 5 squared. I'm just going to leave it for now. And then I can simplify this one step further. I get 16 plus, and I'm going to leave the b plus 5 squared in parentheses. Now from here I realize that I can't really simplify this any further unless I get rid of the square root. And my knowledge of square roots tells me that I can now undo the square root on the right-hand side of the equation if I square both sides of the equation. So if I square the left-hand side and the right-hand side, the left-hand side becomes 25, and on the right-hand side, the square root and the squared undo each other, and I'm left with 16 plus, still in parentheses, b plus 5 quantity squared. Now from here I can continue and go a little bit further, so I can subtract 16 from both sides, and I'm going to bump this up here. I now end up with 9 is equal to b plus 5 quantity squared. And here's where I have to think back to chapter 10, because I know that if I square root both sides, that will undo the squared. But I need to be careful here because I'm square rooting a squared. I know that there are two things that when squared equal 9. 3 and negative 3. So I need to keep that in mind. I know that b plus 5 could potentially equal 3, or b plus 5 could potentially equal negative 3, because those when squared give me 9. So now if I subtract 5 from each side, I find out that a value of b is equal to negative 2, or a value of b is equal to negative 8, will result in a distance of 5 units. So basically it's saying that there are two potential values for b that could result in a point that has a distance of 5 units from the point 3, negative 5. So finally we're going to look at the midpoint formula and how we can essentially find the point that is exactly in between 2 points. So if you look here, you'll see points Q and point T. And what we're trying to do with point Q and T is we're trying to find the number that is exactly in between those 2 points. And if you look carefully, you'll notice there's a very special relationship between Q, R, and T. Now if you look at Q and T, what you will notice is that the x-coordinate for R of negative 6 is exactly in the middle, or the average of, the x-coordinate for point Q and the x-coordinate for point T. Here you'll notice that if you add 3 to point Q's x-coordinate, it brings you to the x-coordinate of R. And then if you add 3 to R's x-coordinate, it brings you to the x-coordinate of T. So there's proof that the x-coordinate of R is exactly the middle, or the average, between the x-coordinate for Q and the x-coordinate for T. So from here, then if we look at the y-coordinates, you'll notice this exact same thing. You have negative 1, 3, and 7, where 3 is exactly in the middle of Q's y-coordinate and T's y-coordinate, because if we were to add 4 to negative 1, it would bring us to 3, and if we were to add 3 and 4 together, it would bring us to 7. So if you want a formal equation for this, really what this is saying is that the coordinate for the midpoint between 2 points is the average of the x-coordinates and the average of the y-coordinate. So that midpoint is exactly in between. So you'll take x1 plus x2 and divide it by 2. That's how you find an average, is you add up the 2 items and you divide by 2. And then the same thing with the y values. y1 plus y2 divided by 2, because we have 2 items. So it is the average. It is the exact midpoint, the middle between the 2 x-coordinates and the middle between the 2 y-coordinates. All right, so let's take what we just learned and let's apply the midpoint formula. So you see here it says find the midpoint for a segment with endpoints -3, 5, and 11, -1. So what I'm going to do is over here on the right-hand side, I'm going to write, okay, we have an endpoint of negative 3 comma 5. We have another endpoint of 11 comma negative 1. And then I have a midpoint that I'm trying to find that I don't yet know. Now, I know that the midpoint is the average of the x's and the average of the y's. So here I can say, okay, negative 3 plus 11 divided by 2. I'm focusing on the x coordinates here, and I'm going to find their average. Negative 3 plus 11 is 8. 8 divided by 2 leaves me with 4. So my x coordinate for my midpoint is 4. Then I'm going to do the same thing with my y's. I'm going to find the average of the y's, which in this case is negative 1 plus 5, all divided by 2. And negative 1 plus 5 is 4. 4 divided by 2 is 2. And then I can check this by making sure that the midpoint is really in the middle of the two x coordinates and the middle of the two y coordinates. So here, to go from negative 3 to 4, I would need to add 7. And to go from 4 to 11, I would again need to add 7. So I can see that I'm adding 7 to get from endpoint to midpoint to endpoint. Then if I look over here at the y coordinates, to go from 5 to 2, I would need to subtract 3. And then to go from 2 to negative 1, I would also need to subtract 3. So again, the 2 is exactly in between 5 and negative 1. So now at this point, I can state for a fact that my midpoint between the two endpoints provided is 4, 2. Now thinking about this in a different way, it says find the other endpoint of a segment with one endpoint. So I have an endpoint of 1, 4. I have a midpoint of 5, 1, and I'm looking for my other endpoint. So I know that my midpoint is exactly in the middle. So what I'm going to do is I'm going to use my knowledge from this picture right here to help me find my other endpoint. I know that to go from 1 to 5, I added 4. And I also know that my midpoint is exactly in between the two endpoints. And so in order for 5 to be the same distance from the second endpoint, I would need to add 4 to 5. And if I do 5 plus 4, that brings me to 9. Then if I go over to the x-coordinate, 4 to 1, I would need to subtract 3, so I want to apply the same pattern here, and that brings me to negative 2. So here I have an endpoint of 9, negative 2. And then what I could do is I could use my formula and make sure that my two endpoints provide me with my midpoint. So if we find the average here, it would be 9 plus 1 divided by 2, which would be 9 plus 1 is 10 divided by 2 gives me 5. And then I need to find the average of the y's, so 4 plus negative 2 divided by 2. 4 plus negative 2 is 2, divided by 2 is 1. So we can see that those two endpoints bring me to my midpoint, and as a result, the endpoint that I found is correct. Alright, so if you feel confident, what I'd like you to do is try these two on your own. And if you're still struggling a little bit, you can continue watching the video. Regardless of what you choose, you should still be checking your answers at the very, very end. So the first one says to find the midpoint of a segment with the two endpoints 2, negative 6 and 5, negative 12. I know that the midpoint is the average of these two, so I'm going to find the average of the x values, which would be negative 5 plus 2 divided by 2. Negative 5 plus 2 is 3. And then 3 divided by 2 is 1.5. And then secondly, I need to find the average of my two y values. So I have negative 6 plus 12 divided by 2. Negative 6 plus 12 is 6. And then divided by 2 is 3. So then I can see here that I have my new midpoint of 1.5, 3. All right, finally, if I look at the second one, they give me one endpoint at negative 2, negative 3. I then have the midpoint, which is at 3, negative 7, and I need to find the other endpoint. So here I can use the equations if I choose, but I know that it's quite a bit quicker if I just apply what I know about a midpoint. So here, to go from negative 2 to positive 3, I added 5. So if I repeat that same pattern on the other side, 3 plus 5 is 8. And then from here, to go from negative 3 to negative 7, I subtracted 4. So if I apply that same pattern, I get negative 11, and I find that my other endpoint is 8 comma negative 11. And then if I test this out and make sure that it is in fact the correct endpoint, if I find the averages of negative 2 plus 8 divided by 2, that would be 6 divided by 2, which is 3, and that matches my midpoint. And then if I do the same thing with the y-coordinates, I get negative 3 plus negative 11 divided by 2. Negative 3 plus negative 11 is negative 14 divided by 2 is negative 7. And again, that matches my midpoint.